Cloud computing, a comprehensive overview. Cloud computing has revolutionized the way we interact with technology, transforming how businesses operate and individuals access services. It's no longer just a buzzword. It's a fundamental shift in how computing resources are provisioned, managed, and consumed. In essence, cloud computing is the on-demand delivery of IT resources. Everything from applications to data centers over the internet. Instead of owning and maintaining physical data centers and servers, you can access technology services as you need them from a cloud provider like Amazon Web Services, AWS, Microsoft Azure, or Google Cloud Platform, GCP, the core concepts. At the heart of cloud computing lies the concept of shared resources. Cloud providers maintain large data centers with vast amounts of computing power, storage, and networking infrastructure. These resources are then virtualized and made available to users over the internet. This shared responsibility model allows users to benefit from economies of scale, paying only for the resources they consume, much like paying for electricity or water. Several key characteristics define cloud computing. On-demand self-service. Users can provision resources as needed without requiring human interaction with the service provider. This self-service model empowers users to scale their resources up or down quickly, responding to changing demands in real time. Broad network access. Cloud resources are accessible over the network through standard mechanisms, typically via the internet. This accessibility ensures that users can access their data and applications from anywhere with an internet connection, using a variety of devices. Resource pooling. The provider's computing resources are pooled to serve multiple clients, with different physical and virtual resources dynamically assigned according to demand. This pooling allows for efficient utilization of resources and reduces costs for both the provider and the user. Rapid elasticity. Resources can be scaled elastically, meaning they can be increased or decreased quickly and automatically based on the workload. This elasticity allows users to handle spikes in demand without over-provisioning resources. Measured service. Cloud systems automatically measure and control resource usage, providing transparency for both the provider and the user. This metering allows users to pay only for what they consume, promoting cost optimization. Types of cloud computing services. Cloud computing offers a variety of service models, each catering to different needs. Infrastructure as a service. IaaS. IaaS provides users with access to fundamental computing resources, such as virtual machines, storage, and networks. Users have control over the operating system and applications, but the provider manages the underlying infrastructure. Examples include AWS EC2, Azure Virtual Machines, and Google Compute Engine. IaaS is ideal for organizations that want to build and manage their own applications and infrastructure. Platform as a service, PaaS. PaaS provides a platform for developing, deploying, and managing applications. Users don't have to worry about managing the underlying infrastructure, including servers, operating systems, and databases. Examples include AWS Elastic Beanstalk, Azure App Service, and Google App Engine. PaaS is well suited for developers who want to focus on building and deploying applications without the complexities of infrastructure management. Software as a service, SaaS. SaaS provides users with access to software applications over the internet. Users typically pay a subscription fee to use the software, and the provider manages the application and the underlying infrastructure. Examples include Salesforce, Google Workspace, and Microsoft 365. SaaS is a good option for users who want to use software without having to manage it. Deployment models. Cloud computing can be deployed in different models, depending on the specific requirements. Public cloud. The public cloud is owned and operated by a third-party provider and made available to the general public. Public clouds offer scalability, cost-effectiveness, and high availability. Private cloud. A private cloud is operated solely for a single organization. It can be located on premises or hosted by a third-party provider. Private clouds offer greater control and security, but they can be more expensive than public clouds. Hybrid cloud. A hybrid cloud combines public and private clouds, allowing data and applications to be moved between the two environments. Hybrid clouds offer flexibility and allow organizations to leverage the benefits of both public and private clouds. Community cloud. A community cloud is shared by a specific community of users with similar requirements. It can be owned and operated by one or more of the organizations in the community or by a third-party provider. Benefits of cloud computing. Cloud computing offers numerous benefits, making it an attractive option for organizations of all sizes. Cost savings. Cloud computing can reduce IT costs by eliminating the need to invest in and maintain expensive hardware and software. Users pay only for the resources they consume, reducing capital expenditures and operational expenses. Scalability and elasticity. Cloud resources can be scaled up or down quickly and easily, allowing organizations to respond to changing demands without over-provisioning. This elasticity ensures that resources are available when needed, while minimizing costs during periods of low demand. Increased agility. Cloud computing enables organizations to deploy applications and services quickly and easily, reducing time to market. The self-service model empowers users to provision resources on demand, accelerating development and deployment cycles. Improved collaboration. Cloud-based applications and services can be accessed from anywhere with an internet connection, facilitating collaboration among geographically dispersed teams. Cloud storage and file sharing services enable seamless sharing of information and documents. Enhanced security. Cloud providers invest heavily in security measures to protect their infrastructure and customer data. While security concerns still exist, cloud providers often have more robust security capabilities than smaller organizations can afford to implement on their own. Focus on core business. By outsourcing IT infrastructure and management to a cloud provider, organizations can focus on their core business activities. This allows them to allocate resources to innovation and strategic initiatives, rather than managing complex IT systems. Challenges of cloud computing. While cloud computing offers many benefits, it also presents some challenges. Security and privacy. Data security and privacy are major concerns for organizations considering cloud adoption. Organizations need to ensure that their data is protected from unauthorized access and breaches. Vendor lock-in. Migrating data and applications between cloud providers can be complex and expensive, leading to vendor lock-in. Organizations need to carefully consider their cloud strategy and choose providers that offer flexibility and interoperability. Connectivity and downtime. Cloud services rely on internet connectivity, so outages or slow connections can impact access to data and applications. Organizations need to have contingency plans in place to mitigate the impact of downtime. Compliance and regulatory requirements. Certain industries have specific compliance and regulatory requirements that must be met when using cloud services. Organizations need to ensure that their cloud provider can meet these requirements. Lack of control. Organizations may have less control over their IT infrastructure in the cloud compared to on-premises deployments. This can be a concern for organizations with strict security or compliance requirements. The future of cloud computing. Cloud computing continues to evolve rapidly, with new technologies and services emerging constantly. The future of cloud computing is likely to be shaped by several key trends. Serverless computing. Serverless computing allows developers to run code without managing servers. This approach simplifies application development and reduces operational overhead. Edge computing. Edge computing brings computation closer to the data source, reducing latency and improving performance. This is particularly important for applications that require real-time processing, such as IoT and AI, artificial intelligence and machine learning. Cloud platforms are increasingly offering AI and machine learning services, enabling organizations to build intelligent applications and gain insights from their data. Containerization and Kubernetes. Containerization technologies like Docker and orchestration platforms like Kubernetes are making it easier to deploy and manage applications in the cloud. Multi-cloud and hybrid cloud strategies. Organizations are increasingly adopting multi-cloud and hybrid cloud strategies to avoid vendor lock-in and leverage the best features of different cloud providers. Conclusion. Cloud computing has become an integral part of the IT landscape, offering organizations a flexible, scalable, and cost-effective way to access computing resources. While challenges exist, the benefits of cloud computing are undeniable. As technology continues to advance, cloud computing is poised to play an even greater role in shaping the future of business and technology. By understanding the core concepts, service models, and deployment options, organizations can make informed decisions about how to leverage cloud computing to achieve their business goals.